our new section is on thermodynamics. Our first section of it is temperature, and we get to move on because we rocked the last one out of the park, so let's move on. So objectives. I will be able to understand temperature, its units, and the background definitions. We'll be taking notes from video, discussing vocabulary with partners, and writing explanations. So temperature. Temperature is a measure of the average kinetic energy per molecule. So this theory states that all matter is made up of atoms or molecules in constant motion. The faster the molecules move, the higher the temperature. Thermal energy. Thermal energy is the total internal energy of an object, the sum of its molecular, kinetic, and potential energies. So thermal energy equals potential energy plus kinetic energy. So the spring analogies are helpful. So again, temperature is related to the kinetic activity of the molecules, whereas expansion and phase changes of substances are more related to potential energy, and which is not true in all cases. So a good beginning is to define temperature as the average kinetic energy per molecule. So if we look at this, we have temperature is equal to the sum of all of the kinetic energy over force. So an important thing is we need to convert temperature Fahrenheit to Celsius. We do Celsius equals Fahrenheit minus 32 degrees divided by 1.8. Celsius to Fahrenheit is 1.8 times the Celsius plus 32 degrees. And then we do Celsius to Kelvin. Kelvin is equal to whatever Celsius we have plus 273. So we have a small example here. So what is the temperature in Fahrenheit if an object has a temperature of 135 degrees? So we're going from Celsius to Fahrenheit. So if we look back at the equation, we do 1.8 C plus 32. So it's right here, 1.8 C plus 32. So 1.8 times 135 plus 32 gives me 243 plus 32, which is 275. So the kinetic molecular theory. It was once commonly believed that heat was an invisible substance. It had a name called a caloric, and it was believed that it could be transferred between objects but not created or destroyed. So it is replaced with the kinetic molecular theory. This new theory stated that all matter is made up of atoms, molecules in constant motion. The faster they move, the hotter an object will be. So really, this is the most important part to write about this. So internal energy, also called thermal energy, is the energy an object or substance has due to the kinetic and potential energies. So to sum it up, really, the hotter the something is, the faster its molecules are moving or vibrating, and the higher its temperature. So internal energy versus heat. Heat refers to energy that's transferred. So heat is internal energy which is transferred between bodies. So a hot potato does not possess heat, rather it possesses a good deal of internal energy on account of the motion of its molecules. So if that potato is dropped in a bowl of cold water, we can talk about heat. There is a heat flow from the hot potato to the cold water. Or if we're just touching the hot potato, there is a heat flow from the potato to our hand. So everything looks to go to equilibrium, and the great sign here is equal because they want it balanced on both sides. So heat is defined as transfer thermal energy. Two objects are in thermal equilibrium if and only if they have the same temperature. So there's a lot of definitions here. We're going to get them in the note card vocabulary. And then our scales. We have Fahrenheit on this side. We have Celsius, and if you notice, Celsius starts at 0, Fahrenheit starts at 32. Okay, and the high point for boiling for Celsius is 100, and the high point for boiling in Fahrenheit is 212. So just to compare the intervals, 100 degrees Celsius is equal to 180 degrees Fahrenheit. 5 degrees Celsius is equal to 9 degrees Fahrenheit. So if the temperature changes from 79 Fahrenheit to 70 degrees, it means a decrease of 5 degrees centigrade. But of course we have the conversion, so it really doesn't matter. So heat is not something an object has, but rather something it can absorb or give up. The heat lost by the hot coals is equal to that gained by the water. So heat, the word here is transfer. In my ugly handwriting. So here's a different one by conduction. Conduction is a process by which heat energy is transferred by adjacent molecular collisions inside a material. So that means they have to be touching. So heat transfer by touching. And then we have heat transfer by convection. Convection is the process by which heat energy is transferred by the actual mass motion of a heated fluid. So this is going through the air. So convection is significantly affected by geometry of heat surfaces, walls, ceiling, floor. So heat transfer by radiation is a process by which heat energy is transferred by electromagnetic waves. So this is actually by light waves, well not light waves, but electromagnetic, and not just by passing through the air. And so there's no medium. So this is important to understand. So let's jump to units of heat. So 1 calorie is the quantity of heat required to raise the temperature of 1 gram of water by 1 degree centigrade. And then we have a kilocalorie. So is the quantity of heat required to raise the temperature of 1 kilogram of water by 1 centigrade. So 1 kilogram. So British thermal unit, it's a little bit outdated, really doesn't matter, but a BTU raises it 1 pound of water to 1 Fahrenheit, but it's an outdated unit, so we're not even going to use it, so blah. And then the last one, the SI unit of heat, is the joule. And that is the preferred unit. And just jot all these down. Alright, that's pretty much it. Peace it. Have a good day.